Welcome back to our DSA series. Today, we're diving into the world of arrays, your ticket to organize data in programming. Let's make it fun and easy. Picture an array as a row of lockers, each with a unique number. You can store a piece of data in each locker. This helps in organizing your data efficiently. Arrays are super important because they let you quickly access any locker just by knowing its number. Now, let's start with learning how to declare and initialize an array. In the given code snippet 1, it gives the data type of array and ARR is the name of the array. 5 is the size of this array. Voila! You declared your first array. In the code snippet 2, we had initialized 5 values to the array as its size is 5. You can fill up each locker later if you like in this manner, but always remember we start counting from 0, not 1. Need something from your array? Just ask for it by its locker number. Now, we will look at how we can access array elements. Look at this code snippet. In the statement 1, we are accepting the 0th index of the array, that is the element stored at the first position. In the second statement, we are adding 10 to the second index of the array. Remember the index number is second, but when you will look into the array, 10 will be at the third place. Now we have learnt how to declare an array, how to initialize an array, how to enter any element into the array, and how to access the array elements. Now we will look at how we can see all the elements that are stored in an array at once. We can achieve this by using the following code snippet. In this, we are using a for loop that iterates from 0 because the array index starts from 0 and goes up to the maximum index, or we can say the array length that is 5, and it increments every time the loop runs till it is less than 5, and displays all the array elements. Now, what are the advantages and disadvantages of the arrays? Arrays are like having your own super organized shelf, but it also comes with certain pros and cons. The pros of array are that we can access any item faster, and they are more memory efficient because everything is in a row. When it comes to cons of array, it is that the shelf size, when one set cannot be changed, it is fixed. For example, you declare an array of size 50, but actually you store only 30 elements into the array. The rest of the 20 blocks in the row remain empty, so it creates wastage of space and memory. Now we will look into some common operations that we can perform on arrays. Firstly, we can perform traversal of an array, that is, we can have a walk through the array. Secondly, insertion. Insertion deals with adding items into the array. Next comes up deletion, that is, removing items from the array. Searching is used to find an item stored in an array. This might be performed using linear or binary search. Then it comes to sorting for organizing the items stored in the array. This can be performed using various sorting algorithms such as bubble sort or merge sort. Now we will look into each of these common operations using some practical examples. Traversal is basically displaying all the array elements at once. In this code snippet, we have declared an array of size 5 and entered 5 elements into it, and then we have used a for loop to display all the elements of that array. Then comes up insertion. In this code snippet, we have declared 2 variables named position to store the index of the array we need to insert the item to, and variable named value to store the item value for the index we are inserting. Then we have used the for loop that will enable us to insert that element particularly into that index number. Then again, we have used the for loop as we did in traversal to display all the elements of that array after we had added a new element to it. Deletion works quite similar to insertion. As an insertion, we have declared an array, initialized values to it, and then we have declared a variable named position to store the index number that we want to delete. Here, We have implemented the logic of deletion into the first for loop, and in the second for loop we are displaying all the elements of the array after the particular element from the index 2 is deleted. Now we will look how linear search works. Linear search helps us find an element in the array by checking each element one by one. If the element is found, we can return its position. This code snippet searches for the value 3 in the array. We use a for loop to iterate through each element, checking if it matches the value we are searching for. If found, we print the index. Otherwise, we indicate that the value was not found. Next, we will look at how bubble sort works. Bubble sort is a simple algorithm to sort an array by repeatedly swapping adjacent elements if they are in the wrong order. In this code snippet, we use nested for loops to repeatedly compare adjacent elements and swap them if they are in the wrong order. This process continues until the entire array is sorted. After sorting, we print the sorted array. Let's move on to real-world applications of arrays. Arrays are everywhere. Whether you want to have a quick data lookup in databases or understanding scientific computing for numerical simulations and data analysis, each pixel is stored in an array in image processing. Arrays are used in rendering vertices in computer graphics. And that's a wrap on arrays. They're your go-to for organized data storage. Up next, we'll explore strings. Hit that like button, share with your friends, and subscribe to stay in the loop with our DSA series.